The following program is rated G. It is suitable for all audiences.
I am Warner Kunanan.
And I am Lian Cairo Roman.
I am Raymond Suyman.
And we are Electricidad.
Our physics experiment
Discharging and
Discharging of capacitor. So we are about to begin our experiment, but before we begin our experiment, we need to have the following materials.
Concept of the experiment. After sketching the experiment, we need the concept of the experiment as the guideline for the experiment. Plywood. We need a piece of plywood with the size of shirt band paper. It is for placing or attaching the experiment. Electric tape. We need an electric tape for covering the wires. Scissor. We need scissor as the wire cutter. Ruler. We need a ruler for making a line of the sketch of the experiment to show the connection. Glue gun and glue sticks. We need glue gun with glue sticks for sticking all of the materials on the plywood. Wire. We need a wire for the connection of the experiment. Resistor. We need two resistors with 300 ohms for resisting the flow of current to prevent the LED light from explosion. Capacitor. We need a capacitor for storing the energy from the dry cell. Switches. We need two switches for controlling the flow of current. Battery snap connector. We need a battery snap connector for holding the dry cell. Dry cell. We need a 9 volts of battery as the main source of energy for this experiment. LED lights. We need two LED lights for showing that the current is flowing. Once we place the plywood on the table, get the battery and snap connector, then put it on lower left of the plywood. Then, get the resistor 1, connect it to the positive wire of the stop connector, which is the black wire. Then, get a piece of wire, connect it to the resistor. Then, get the LED light 1, connect it to the wire. Then, get a piece of wire again, connect it to the LED light. Then, get the switch 1, connect it to the wire. get a piece of wire again, connect it to the switch 1. Then, get the capacitor, connect it to the wire, make sure it is connected on the positive of the capacitor. Then, get a piece of wire again, connect it to the negative of the capacitor. Then, get a piece of wire again, connect it to the negative wire of the snap connector, which is the red wire. Then, get a piece of wire again, connect it to the wires from the wire of the snap connector and the capacitor. As you can see, we are done in the circuit of the charging phase. Let's now move on to the charging phase. Then, get the resistor 2 again, connect it to the last wire that we have connected. Then, get a piece of wire again, connect it to the resistor 2. Then, get the LED 2, connect it to the wire. Make sure the wire is connected to the negative of the LED. Then, get a piece of wire again, connect it to the positive of LED light. Then, get the switch 2, connect it to the wire. Lastly, get a piece of wire again, connect it to the switch 2, then the other end of wire, connect it to the switch 1.
After making our experiment, I'm going to show you the results of our experiment. This is our experiment, as you can see in the video. Later on, I'm going to discuss how the experiment works. We have experienced some problems before and during the experiment. Before making our experiment, we have encountered the problem in buying the required materials. We have been in different electronic stores to buy the materials because they only have limited stocks of capacitor and resistors, so we need to buy to other stores. Well, in the experiment, we have also experienced a problem or factors that affects the function of the experiment, such as the first one is malfunction of LED lights, the second one is incapable connection of wires, and the last one is disruption of current flow.
This is the final output of our experiment. Let me show you how the capacitor is being charged and discharged. Let me open the switch 1. Once I open the switch 1, the LED 1 is glowing as you can see. This circuit is complete right now, which is the charging phase. The capacitor is being charged already. Let me switch off the switch 1. Once I switch off the switch 1, I will switch on the switch 2. As you can see, the LED 2 is glowing for a little time. As we have seen a while ago, the LED 2 was glowing for a little time because the charge from the capacitor in the charging phase. The charge which is stored in the capacitor is now being utilized to glow the LED 2. It will glow for some time. Since I use 9 volts of battery, the capacitor is high enough so that the LED 2 glows for a little time. Changing the capacitance and resistance of the power will change the glowing time of LED light.
What is a capacitor? A capacitor is a passive device that stores energy in its electric field and returns energy to the circuit whenever required. A capacitor consists of two conducting plates separated by an insulating material or dielectric. When a capacitor is connected to a circuit with direct current source, two processes which are called charging and discharging.
On the other hand, a capacitor is equivalent to an open circuit to direct current because once the charging phase has finished, no more current flows through it. The voltage on a capacitor cannot change abruptly. When the capacitor is disconnected from the power supply, the capacitor is discharging through the resistor and the voltage between the plates drop down gradually to zero.
And for the conclusion of our experiment, no current flow through the dielectric during charging and discharging phase except leakage current. It takes 5 times constant to charge or discharge a capacitor even if it's already somewhat charged. In the charging phase, the capacitor voltage exponentially rises up to source voltage where current exponentially decays down to zero. As switch closes, the charging current causes high surge current, which can only be limited by the series. Discharged capacitor behaves like a short circuit when initially connected in the circuit, means causing surge current initially. A capacitor behaves like an open circuit when it is fully charged, means not allowing current through it. In the discharging phase, the voltage and the current both exponentially decrease down to zero.